Hello everyone, welcome back on another video on power electronics and MATLAB Simulink. In this video, we are going to simulate the single phase grid connected system, and we are feeding the power from the DC source to the AC source, and the AC will be the grid. So what structure we need in this Simulink? So first we will draw the structure, and further we will make a Simulink model and perform the control actions on that model. So what actions we need, what controller and what circuit we need? So we need two circuits. One is the control circuit and one is the power circuit. So the control circuit and the power circuit. So first we will talk about the power circuit. So we are feeding the power into the grid. So we are having the DC source, that is VDC, and that is connected with a H-bridge inverter, and the configurations of the H-bridge inverter will be like this: switch with the anti-parallel diode. So we are using IGBT, and further that is connected with the interfacing inductor, that is the filter inductor, to smoothing the current ripple, and we are having the AC source, that is VG, and this VG is considered as 230 volts at 50 Hz frequency, and this is the IG current, and VDC is considered as 400 volt. So for this one we are having 4 switches: S1, S2, S3 and S4. So for this one, the control circuit is such a way that the grid current will always follow the grid voltage, such that we are having a grid voltage like this, and we are having the grid voltage like this, and grid current will be following in the grid voltage. Okay, so for this one we are sensing the grid voltage, and this grid voltage is feeding to the phase lock loop. In the PLL phase lock loop, it is generating the theta, that is the phase angle, and it is generating the frequency. And if we are getting theta, we are able to get the sine of theta and cos of theta. And if we got the sine theta, our reference current will be equals to the peak value of the reference current into sine theta, that will be our reference current. And from the grid we are having the actual current is IG. So the error signal will be reference current minus grid current, and this error is passes through a controller, and this controller will be making the steady state error equals to 0, and it is generating the modulation index, and that is given to the, and that is compared with a repeating sequence 1 and minus 1, and generating the PWM signal for switch S1 to S4. Okay, so this will be our control actions. So now we will make a Simulink model for the same. Our inverter will feed the power from DC source to the grid. Okay, so let's get started with the Simulink model. So first thing, when you are clicking, double click on this one, you will get, and when you are typing with the keyboard IGBT and diode, the first option will be coming IGBT and diode. So we are using the IGBT with anti-parallel diode. Okay, and we are making the copy of this one. So we are having 4 switches, and we need a DC voltage source. So just click on the screen with the mouse, left click and type a DC voltage source. So it is coming the DC voltage source. Now you need a AC voltage source. So I type AC voltage source and I need a series inductor, that is filter inductor. So for that one I need a series RLC branch. Okay, so series RLC branch you can configure as R, L and C. So I want the L and the inductor value I am keeping as 15 millihenry. And the AC voltage source I am keeping 230 into square root of 2 and the frequency I am keeping as 50. Similarly, the DC voltage source, the DC value I am keeping as 400 volts. Now I am connecting the DC source and I am connecting the inductor with the AC source. To measure the voltage and current and to synchronize the grid voltage with the inductor current, we need a voltage and current sensor. So to configure the voltage and current sensor, we need a voltage measurement block and current measurement block. So the current measurement block will always connected in series, as you can see here, and the voltage measurement block will always connected in the parallel with the source. So now we will be using the go-to block and we are changing the name, that is IG, make it tag visibility is global, and here I am making this is as VG and tag visibility is global. So now this is the power circuit. Further, we need a pulses, PWM pulses to the switch of the inverter, the H-bridge inverter. So we will be connecting the from block and we are giving the name as S1, S2, S3 and S4. Okay, so this is the complete power circuit. Now we will be building the control circuit. The first step to build a control circuit is that we have to generate the sin theta, the angle theta that will be in phase with the grid voltage. So to generate the sin theta, we need a PLL. So for the PLL, we are using second order generalized integrator based phase lock loop. So this is the basic structure of the SOGI second order generalized integrator. So here the grid voltage is given and it is generating two orthogonal signals, V alpha and V beta. These two orthogonal signals, so it is generating two orthogonal signals. This is the V alpha and this is V beta. And these two signals are giving to the alpha beta to DQ frame. So this is a V alpha and this is the V beta, and that is feeding to the alpha beta to DQ0 frame. So it is when it is converting the Q axis equals to 0, then that is subtracting with 0 the reference, this is the actual value, and it is feeding to the PI controller. and this PI controller output is arrayed with the reference frequency, and it is generating the actual frequency, and it is passes through the integrator. So this is omega. Integration of the omega will give the theta, and the same theta is passes through the this one. And if we know the theta, we can able to generate the sine theta and cos theta. First, we will use the from block, and in the from we are changing this to Vg, and we are using the add block. We are using the GAN block, discrete time integrator, multiply, then alpha beta to dq0 max dmax constant blocks. So these are the things we need for the PLL. So this Vg will make a round shape. Vg is passes to this summation block, and output is passes to. So we will make a subsystem for this one, making the control G. So now this will be the Vg, this will be the V beta, and this will be V alpha, and this will be omega, and this gain is we are considering 1.56. So this is passes through the alpha beta, to dq0, and again in dq0 we are making x is equal to 0. This is dq, and we are changing the property of this one. This is a pi discrete time and parallel, and the sample is 1e minus 5. This is 43, and this is 723. So here we are giving theta. Okay, so once it is generating a theta, now we have to generate the sine theta and cos theta. So we are using the function block, and in the function block we are writing a sine of u1, and this sine of u1 is multiplying with the reference value, So this is our reference value, and we are considering the 5 ampere, and this is again comparing with the grid current, and this is passes through the PI controller, and we are making a saturation block. Output is 1 and -1, and we need a relational operator and gain and repeating sequence, and the frequency which we are using, that is 10 kilohertz, and output is okay. So I have considered these S1, S2, S3 and S4, and this value is 20 and 257. So now we will connect a scope, and we will see the grid voltage and the grid current. So we have connected the grid voltage and grid current, and we will on the scope. So now we will run the simulation, and we have set the current as 3 ampere reference current. Now we will change the reference current to 5, again 8, and 10, again 4, 5. So in this case, our inverter is able to track the current, reference, and the so you can see that the voltage and the current are in out of phase. There is a need there we need to change something in the parallel part. So in the parallel part, what we do, we will do put a gain with a -1. So once you run it, and you will able to see that the voltage and the current will be in the same phase. So now you can see that voltage and current are in the same phase. So now if we look at the total harmonic distortion in the current, so the first we will make a data logging for the T, and we will keep the variable name as a THD, and we will run one more time this. So now we will see that in the power GUI block. So I have kept the power GUI block here, and I will go to the FFT analysis. And in the FFT analysis, if I go to THD, and the frequency I'll select the 50, and start time I'll select the 0.5, and for the one cycle I am making a THD. So this is for the voltage. Now for the current, the THD is 3.67%. As you can see here in the current TSG is 3.67% and the fundamental is 4.819. So this is the single phase grid connected system, the simulation of single phase grid connected system with a SOGI PLL, and for the current control we have used the normal PI controller. So if you like this video, please share this videos to your friends, colleagues and your researchers, so it will be beneficial who is working towards the grid connected system. And don't forget to like, share and subscribe my channel. Thank you.